Welcome back to UNISA, and what an eye-opener it's been this morning. We are, of course, coming to you from the west of Johannesburg. This is at the Florida campus in Roodepoort, and it's been such an eye-opener this morning looking at what UNISA is doing. And as we said, gone are the days when it was just people who had law degrees and commerce degrees and something in humanities. UNISA is doing some really groundbreaking stuff. And of course, when we look at placement for students, for learners who leave school, this is definitely an option. And I must say, I've been so impressed by what I've heard and seen this morning. So you may notice that I've changed out of my blue lab coat because I came in here, very sterile environment. It looks like you're walking through, coming into a fridge, literally. Very sterile. Was told to wear the gloves, told to wear the white lab coat. And I'm joined now by Professor Ntwasa, who's here, Monde Ntwasa, to tell us more about where we are and what we're doing here, biotechnology.
So this is an area of biotechnology where you are now, and particularly this room is where we do cell culture, where we study all kinds of molecular reactions that happen inside a cell, doing now outside an animal, but we're doing it in cell. So this biotechnology is one of the 10 catalytic niche areas. And in this room, most of the students are students that do work in my group, which is focusing on anti-cancer drug discovery. We've also strayed now into also looking at infectious diseases, particularly from the time of COVID. And so it's basically a place of natural sciences and biotechnology. But I need to say that this is a very young college, but within a very short time. I think we already started working about 10 years ago. And but within a very short, in 5 years, we managed to get 1% of the university's innovation, which is very big in terms of the time that we have taken. So, and this is really because of a serious investment by the university in terms of equipment, state-of-the-art equipment, like you're going to see now, the equipment that we're going to show you. And I can tell you that piece of equipment that we're going to show you now, our college is the only place you can find in the continent. Oh, let's so there's we want to see that yeah, this we call it Jess, and as Sibusiso is going to show you. So this is the major investment that is done, that the university has put into biotechnology, is absolutely amazing, and it's no wonder that we're doing so well in the rankings of the internationally, because it's not something that's just happening randomly. It's because the university has actually invested seriously in it. So yes,
we're going to walk through because I want to see this amazing piece of equipment, but of course, anti-cancer
drug. Oh, this is very important.
And the research that goes into
so
this.
The work that we're doing, we actually designed, using all kinds of technologies, a new drug, anti-cancer drug. It's a small molecule drug. We actually modified an already existing drug, which is used now to treat cholesterol, but we've modified it now to treat cancer, particularly colon cancer. And this new drug has actually been patented internationally, and we've got another one that is already going preclinical studies now. And we think that it's going to go into clinical study because what we see is proof of concept that the drug will actually work. This is going to be a groundbreaking thing for South Africa because, in fact, it will be the second small molecule drug in the continent. The first one being at the University of Cape Town, where Prof. Shibale. Now ours will be a second drug that goes into clinical trial if it does. So we must look into that space. So we're busy with the anti-cancer drugs and also with the anti-COVID drug.
All right. Yeah. Prof, let me leave you here to do some work as I make my way to Sibusiso and telling you about this machine, the only one here on the African continent. So Sibusiso, good morning. You know, just talk to us about who you are and what it is that you do here.
Awesome. Good morning, Sakina. I'm Sibusiso Malindisa, a lecturer here at UNISA for biotechnology, but I'm also completing my PhD. And I would like to show you this amazing instrument, which is the star of the show. This instrument, which we call Jess. The instrument called Jess is the instrument that we use now to figure out, once we have treated the cancer cells with the different drugs, now we need to show what pathways, what mechanisms is the drug using, because we need to understand exactly how does a drug result in cancer cell death, so that when we now take it to humans, we understand the molecular pathway.
Please show us.
Awesome. So what we do is we treat our cells with the drugs, and then what we do is we extract proteins and we put them in these nice tiny wells. And then what this machine allows us to do is, when we are ready to detect, is we put this module in, we close the machine, and the machine, what it does, it will detect proteins in every sample that we have loaded here. But what is nice really about this machine is that it does this in 3 hours. You know, the conventional way of detecting this protein usually takes 3 to 4 days. But UNISA has invested in this machine, which allows us to do all of that work in 3 hours. So which is very important for us who are part-time students, because we usually don't have the time to spend here. So if UNISA invests more in this, then we can finish our degrees much quicker, but also learning some of the cutting-edge technologies that we do not that mostly are found in the Western world. So at least you get the benefit of learning new technologies, but also finishing your degree within time.
So there you have it, Jess, and that is quite phenomenal, as Sibusiso says, allows them to do work that would generally take 3 to 4 days and get those results in 3 hours. And of course, this is the only one on the continent, Jess, and it's here at UNISA. So also, you know, much more going on here. So talk to us about some of the other things that we are seeing around us, and what you guys are busy with.
Absolutely. Okay, so this is one of our many instruments that we use. So what we do here is, now we want to figure out how the cells die. So once we've given them the drug, we want to know exactly in what way are they dying. And if you look at this closely, you can see the overall population of cells, but then here it can tell us exactly how many are alive and how many are dead following our treatment. So this is quite important for us to determine also the dosages that we need to use going forward.
Well, we know what a problem we have in South Africa with cancer, and of course cancer research, and UNISA here leading the way. And I think this has been the picture that we have come across here this morning at UNISA, talking about those 10 niche catalytic areas that the university have embarked on. And hopefully, you know, this has given you another option in terms of where to go to study, because as the Vice Chancellor told us right at the start, you know, it's not just distance learning anymore, it's online learning and it's contact learning, as you can see right here and now. And everybody doing their bit, leading cancer research. And you heard also from the Nanotechnology and Water Sustainability Department, they also leading along with Stellenbosch University. So it is no mean feat here at UNISA and all the work that is happening here. So we hope that this has been as eye-opening for you as it has been for me this morning. We're coming to you from the UNISA campus in Florida, in Roodepoort, west of Johannesburg. And with that, we hope to hear from you. Let us know what you thought of what you saw here. And of course, it's back to studio, but to Studio 9 with Ayanda Nyati to tell us what's coming up on the agenda.
All right, thanks very much, Sakina. Indeed, definitely the geek in us very excited this morning about all those amazing things that are taking place there. So thanks for showing us.